Hello, everyone. I hope you enjoyed lunch, and glad to be back here on stage with the cloud-native community of Munich. So this year, I'd like to talk to you about the OpenSearch open source project. But just to get to know you, with a show of hands, who is familiar with OpenSearch? Okay, we have quite a few. And who uses or has used OpenSearch in production, testing, something? Okay, great. For the ones who use OpenSearch, come to me after the talk. I have a limited edition, special edition of OpenSearch socks, especially for the users. And then I'll ask you how you use it. Curious to hear about your experiences. So a bit about me. My name is Dotan Horovits. I'm the evangelist for the OpenSearch project. And actually, the post that you can see here is from a few months ago, from April, when we held the OpenSearch Con Europe. That's the yearly event for the OpenSearch community. This year held in Amsterdam, as the logos might suggest. But actually, last year's OpenSearch Con Europe was held here in Germany, in Berlin. So great thing. I'm also a senior developer advocate at the AWS open source team, leading the global advocacy around OpenSearch and around open source observability. Happy to talk about these as well. Outside of my day job, I also am a CNCF ambassador. So again, very excited to meet again with the cloud native community here. And I also run the Open Observability Talks podcast in English, already 6th year. So if you're into DevOps, open source, observability, and the likes, check it out on your favorite podcast app. And as you can see, my surname is my handle everywhere, Horovits. So if you want to catch up after the talk, or if you're tweeting something or posting something from this talk, feel free to tag me. So for those who are not familiar with OpenSearch, OpenSearch started as a fork of Elasticsearch back in early 2021, after ElasticNV, the company behind the project, decided to relicense Elasticsearch and other components of the ELK stack to a non-open source license, to SSPL. And for obvious reasons, the community still wanted an open source alternative for search, analytics, observability, and the likes. And AWS stepped up and created this fork. So that's how it started, as a fork of the latest Apache 2.0 licensed version, 7.10. And that was 4 years ago. In fact, that was exactly 4 years ago. The 1.0, the first stable release of OpenSearch, came out July 2021. So I guess we can wish happy birthday to the OpenSearch project. So give it a round of applause. 4 years, amazing 4 years. Actually, I want to do an experiment with you. Would you like to wish a very short video to the global community from the CNCF community here? Let's do a very short one. Just say happy birthday. Let's see if it works. First time on stage, doing it. So just say happy birthday, OpenSearch. 1, 2, 3. Happy birthday, OpenSearch. I promise to post it, and I will tag everyone. No, just kidding. But you tag yourself. So anyway, really amazing. And the project has come a long way throughout these 4 years. As you can see, the project has had over 1 billion downloads to date, 26 releases across over 130 different GitHub repos. And it's really all thanks to this amazing community. You see the numbers here. Over 1,000 contributors from dozens of companies, really exciting. And the results speak for themselves. If you check today the DB engines, you'll see that OpenSearch is top fourth ranked engine, search engine. Really exciting to see that. It's been that for some time now, for really good. And the exciting news from back in September in Vienna, not far away from here, at Open Source Summit Europe, we've announced donating, essentially, moving the project over to the Linux Foundation. So today, this is a top-level project under the Linux Foundation. We created the OpenSearch Software Foundation as a non-profit under the Linux Foundation, where we have our governing board in place, technical steering committee with members from across the community. And you can see companies like SAP, Uber, NetApp. We have even fellows here from SAP that I congratulated for this amazing contributions that they've been joining in and helping us toward the future of this project. So that's a bit of a background about the project and about the community. And now let's talk about the tech stack. So at the core of OpenSearch, there's OpenSearch Core, the distributed search engine built on Apache Lucene. Essentially a document storage for indexing, storing, and querying documents with also built-in vector database. So essentially you store documents, think about like JSONs with non-structured or structured data, plain text, whatnot. Also different types of data like geospatial coordinates and the likes, and then querying that over REST API very intuitively. So that's the core. Then you have the OpenSearch dashboards. That's the UI, the front end tool through which you can query visually, you can create dashboards, you can create alerts, reports, and all of the likes. And Data Prepper is a lightweight data collector for enriching, transforming, aggregating, essentially processing the data and preparing it for indexing. These are the main components. There are lots of other components, client libraries, integrations that I'll go into a bit later. And obviously, it's cloud native. You have a Helm chart, you can deploy it on Kubernetes. You have a Docker image, you can deploy it on Docker, and so on. So cloud native by design. Now let's talk about how people use OpenSearch. Like any database or data store, it can be used for multiple use cases, but these are the 4 use cases that I can share. First, the search. Of course, companies that want to build up their enterprise search, their catalog search, e-commerce websites, and the like. Then it's widely used for log analytics and for observability purposes. Then we see also growing use cases as a backend for AI and ML applications, thanks to its built-in vector database and the integrations to platforms such as LangChain, LlamaIndex, and the likes. And also security analytics, detecting, investigating, and responding to threats in real time. These are the main use cases. Let's spend some more time on these. So let's start with search. That's the core of the project, where it started from, essentially matching terms to objects in a catalog. So like the example here that you can see, let's see if I can highlight this one here. So you have this, I want a couch, what does it say? A convertible olive couch, and you get the results. So matching the text, imagine the product description, free text, into your query, lexical keyword search, and then you get the results also ranked based on the relevance. So it's not just getting results, it's results based on relevance. It's the BM25 algorithms, for those who know it from Lucene. And you get it ranked by the results based on the term frequency, occurrence models, and so on. Then there are facets. Facets are what you usually see on the left-hand side, these parts, where you can then tag and say, no, I want a couch from this style, this color, this material, this brand, and then it narrows down your search based on attributes. That's faceting. Geospatial, so we can search based on a geographical area, like a bounding box or bounding shape or things like that. So another capability, fuzzy matching. So imagine that one letter got misspelled or dropped, or maybe 2 letters, depending on you, and you still want to find it. You can think about it like what Google says, did you mean, when you have a typo, so fuzzy matching. And as I mentioned, vector search. So representing, in this case, your unstructured data as vector embeddings in a multi-dimensional space, and then finding the proximity vectors that are close by in this multi-dimensional space. And let's have a quick demo for that. Let's see. Okay, where's my mouse? Here we go. So let's do this. And here I prepared a dashboard We all love dashboards. This one is for e-commerce. So again, imagine an e-commerce, you need to monitor your website, and you can build something along these lines, things that you'd expect, the sold products of the day, breakdown of sales per gender, how many male and female, and others, average sales price, average sold quantity. You can see trends over time and break them down by the different categories, men's clothing, men's accessories, women's clothing, and so on. You can see the promotion tracking. So I don't know if you can see this little bell that is the promotion. And then you can see how it impacted the sales, the revenue, where the revenue comes from in an interactive map around the world, the top-selling products, and so on and so forth. Of course, you can also filter that. You can say, no, I'm only interested in this and that manufacturer. You apply, and then immediately all the dashboard will reflect only that filtered search. And you can see here, this is the added filter. This is the built-in filter, but you don't need to count on someone baking it into the dashboard. You can write it yourself. You can say, I want to see only, you don't even need to remember, it automatically populates the fields. Day of week is, also auto-populates the values, Saturday. Save. And again, immediately, all the dashboard zooms in on Saturday. You see that the rest of the days disappeared. We only see the sales over on Saturday. So this is dashboarding that you can do yourselves. So let's switch over again to the deck. Here we go. And so that was search. Now let's talk about observability. On the observability front, you can use OpenSearch to detect, diagnose, and remedy issues that affect your performance. It could be on your infrastructure, it could be in your application, depending on your telemetry. Many use it for log analytics, so essentially throwing your mounts of logs onto the cluster, index them, and then start asking questions about what happened in your logs. You know, these long messages that have lots of valuable information, unstructured information. There are many features around that. So many use spend time in discover pane, and lots of other things like log tail, log surround, log patterns, and so on. You can query your data with Lucene, for those who are convenient and are familiar with Lucene. There's also PPL, piped processing language, that is an open source language that we've released that actually allows you to query across the different signals, not just logs, metrics, traces, and so on. You can also even query, by the way, natural language processing. You can write, show me all the problematic pods in this cluster, and it will translate it into a PPL query for you. Pretty cool. ML again. And of course, built-in integration with the cloud-native stack, OpenTelemetry, Jaeger, Prometheus, and the like. And again, let's just see and get a taste instead of slideware. So let me switch again to show you a very quick demo. This one that I prepared is on weblogs. Okay, and this time I started with the Discover pane before we saw a dashboard. This is the Discover pane. Many love it and just spend time here. You can write your queries here. And first of all, I want to show you what a document is. So when I say a document, I'm showing you in JSON deliberately. Essentially, it will be that. It will be lots of information about the memory, the event, the time, the hour, and more. And this is the part that we usually are very interested in, the message body that has a lot of useful information. We see here an IP address. We see here, what is it? I see here Mozilla 5.0. I see here Gecko. I see Firefox. Lots of information, x86, 64. Lots of valuable information is plain text, unindexed, unstructured inside your message body. So this is what we want to dig into. And again, of course, you can create then the dashboard for that. So this is an example dashboard that I prepared. You can see here, I don't know, unique visitors to your website. You can see the breakdown by operating system, how many OS X, how many iOS, how many Windows, and so on. You see here the response codes over time and also where issues occurred. So you can see the correlation between the issues and the response codes. You see overlaid the unique visitors versus average bytes. You can see the files that were downloaded from your website, CSS, GZ, zip, and so on. You can see it in a scatter plot. You can see it in a table. You can see the hotspot in your website when your website is being hit by the most demand and where from around the globe, and so on. So really, the dashboard that you probably are familiar with. And again, let's switch back to the slides. Here we go. OK. So system view, just to understand how it looks like from system architecture point of view. So essentially, a data prepper helps you ingest, enrich, transform your data, and essentially prepare it for analysis, then storing it, indexing and storing it in your cluster. And then you use the pipe processing language or Lucene to query the data, and then you can create all these visualizations that I was talking about, or querying the data visually the way that you find it convenient. Now, zooming into the UI part, this has been one of the biggest areas of focus for the OpenSearch project, because the sheer volume and complexity of the data makes it very challenging and overwhelming. So the goal of the project and the community has been to provide with powerful, easy-to-use UI to manage and visualize your data, to identify and respond quickly to issues, and to share insights inside your team, across teams, and so on. Here, the example, by the way, is an anomaly detection feature that you have visual, so you can actually have a machine learning model monitoring your behavior and then flag anomalies in this behavior, just as an example. Ecosystem is, again, a very important part, especially for the observability use case of the project, because each system that you integrate and monitor has its own choice of collectors and storage and so on. So really, it's been the ability to tailor your own observability with OpenSearch has been a main focus, and you see easy integrations with popular tools for collecting, managing, visualizing information. You'll recognize many of the logos here, and there are more than that. Let's now talk about AI/ML. That's the hot topic, definitely this year, so I have to say a word about that. And there's actually quite a bit to say about that, because we've seen the trend with the popularity of GenAI. We've seen a trend switching from the search based on lexical search, based on keywords, into search, semantic search based on meaning and intent. So OpenSearch provides out-of-the-box, full-fledged open-source vector database where you can store your dense vector embeddings and then do similarity search on them. It supports both exact and approximate KNN, K nearest neighbor algorithms, as you can see. It supports multimodal search, so not just text. You can index and query on audio, video, images. You can send whole PDFs that contain lots of modalities. Think about this is a chart, and this is a table, and this is a header, and this is a paragraph. So the algorithm will know how to chunk these, and each one will be analyzed by its own analyzer, its own model for that modality. All of this flexibility comes out of the box. In addition to the dense vectors, it also supports neural sparse search. You can bring your own LLM, so I don't know, Claude, DeepSeek, whatever is popular these days. Many of them come out of the box, and very easy to also write integrations for newer ones. MCP, native support for agentic AI. Model context protocol, again, a hot topic these days. You have a built-in MCP server there. So that's about AI/ML. Another area of focus for the community has been performance. Many come to OpenSearch because of its ability to index, ingest, store large volumes of data. But with large volumes of data, obviously, performance comes at a premium. First, for the real-time responsiveness and the user experience, and also for cost savings on storage and indexing, processing, and so on. So as you can see, we've been putting a lot of emphasis on various aspects of the performance, indexing throughput, query latency, storage space reduction, across the board, lots of emphasis about that. And now with that, let's go to the hot news. So I can't be more excited to share with you that we've just recently released the next major release of OpenSearch, version 3.0. So again, a round of applause for the community for this amazing, thank you. the first major release in 3 years. Really, really exciting. That was back in May when 3.0 came out. And a month later, just last month, 3.1 already came out. This is actually from last month at Open Source Summit North America in Denver when we released it. And version 3 is big, and I want to give you a taste of why. So first, it starts with the underlying infrastructure. We've upgraded to the next major release of Lucene, version 10. JDK has been upgraded to the minimum of JDK 21. And the infrastructure brings up a lot of good value and benefits like hardware-level enhancements, SIMD vectorization, more efficient posting, decoding, and many more. And also cleaning up deprecated stuff and making it more future-proof. Next up, one of the biggest evolutions comes from the way that we ingest, transport, and manage data, all the data management, underlying layer and architecture, dozens of new features around that. I'll just give you a taste of 3 significant features that are going to impact each and every user of OpenSearch. First, the support for gRPC and protobuf, realizing faster and more efficient data transport and data processing, and also unlocking the ability to use it with Apache Arrow, Apache Flight, that are more optimized for large data sets and distributed networks. Really cool stuff. Then there's pool-based ingestion that gives you more control over the flow of data and when it's retrieved. So more flexibility on that side, and also the ability to pull from streaming frameworks such as Kafka, Kinesis, Pulsar, Red Panda, and the likes. And last but definitely not least, a significant architecture change is the reader-writer separation. Essentially separating the indexing workload from the search workload. So just think about someone with massive logging needs, with millions of logs per second that needs to scale out the indexing, or someone else entirely on the enterprise side that wants to have 20 plus replicas to query on the massive amounts of support the massive amount of e-commerce queries. This is the type of separation isolation that you get out of that architecture. Continuing on the performance improvements that I mentioned before, with the version 3 release, you'll definitely see it taking a big leap. Initial tests with the 3.0 already showed improvements of 20% on aggregate across high-performing queries, operations, compared to the latest 2.x, and also compared to 1.x release, then you saw 9.5 times faster across key queries. So really, really amazing improvements. And there's great news also on the vector-powered search. We've added GPU acceleration that shows amazing figures. You can see here, like 9.3 times faster index builds, 2 times higher throughput, while reducing costs by more than 3 times and decreasing CPU workloads by 2.5 times. So really, really amazing, leveraging innovative features by NVIDIA, cool stuff. On the observability side, just again, a taste of what we've done. We've enhanced the query insights, a great way to investigate your long-running queries. You have something long-running, you can visually understand why it's like that. Also, smarter anomaly detection with contextual launch. Correlating logs and traces, cross-cluster search for traces. Pipe processing language, that query language, added more than 20 different operations. My favorite on this release is the nested JSON that has been a pain. So now much, much easier to query over nested JSONs and also flatten them and transform them into tabular format for easier querying. So again, just to give you a taste, and there's lots more in store for 3.x, support for OTel and Prometheus, support for natural language queries, a new APM experience, multi-source panels so you can overlay logs, metrics, traces, and visualize them on the same canvas, defining SLO targets directly in the dashboards with real-time status indicators and automated reports, automatically generate alerts from the queries that you ran in the Discover pane. So lots of stuff. By the way, I just had in the Open Observability Talks podcast a dedicated episode about the new major release, and I hosted the governing board chair, Carl Meadows, and the release manager for 3.0, and the technical steering committee member, Pallavi. So lots of good insights, a whole hour of deep dive with the folks who lead the project. Scan the QR code, and also check out the project itself. You can find the project in GitHub, of course, Slack. We have a very active Slack, forums, user groups around the world. By the way, we have a user group even here in Munich, and also others in Berlin and many other locations around the world. So check it out on meetup.com. I actually put all the links in one page because many asked me, and I keep on adding useful links, including, by the way, the demo that I showed is an open playground that you can play with yourselves. So playground links, roadmap, everything I put in on my blog in one page, very easy. So scan the QR code, you'll find all the links. And of course, I'm here today, tomorrow, happy to answer any questions that you might have. And even if you remember a question after the conference, you can find me, as I mentioned. My surname, @Horovits, is my handle everywhere. So just feel free to reach out to me now, after the conference. Happy to talk to you. I'm Dotan Horovits, and thank you very much for listening. And we have a couple of minutes for questions. So who wants a question?
Maybe you teased it with your roadmap slide, but what would be the best approach to monitor OpenSearch? Because there was this Avon exporter some versions ago that has been stale. And if I want to get my monitoring stack with Prometheus filled with metrics of OpenSearch, what would be the best approach?
You want to monitor OpenSearch itself, or you want to use OpenSearch to monitor something? I didn't understand exactly what you're trying to monitor.
I want to use Prometheus to monitor OpenSearch.
So it's OpenSearch has its own native metrics, if that's what you're looking to do. That's a way. And actually, OpenSearch on the flip side has an integration with Prometheus, so you can visualize Prometheus metrics with the OpenSearch dashboards that I showed before. So both sides work, and actually this is going to be a main focus to enhance the Prometheus support in OpenSearch in V3 this year. So stay tuned if this is specifically of interest to you about the Prometheus integration. A lot is coming up on enhancing this part as well. Any other questions? I think we have a gentleman over there.
Hi, thank you for the talk. Just a quick question. I'm not sure whether that was improved in version 3.0, but do you have any plans to improve semantic search support in OpenSearch? Because currently it's pretty painful compared to Elasticsearch to set up that stuff and overly use like standard models for that.
So it's first of all, I don't know what you use in Elasticsearch. I'll put that aside. But painful for OpenSearch, I'd be glad to catch up afterwards to understand. There's lots of ways to work, but semantic search is a main focus. It's been a main focus in 2.x and definitely on 3.x. So curious to hear more after the talk about what the pains that you're experiencing. I can definitely say that the improvements that I mentioned for vector search, it was less the focus of this talk. Actually, last month, I was in Berlin talking at Berlin Buzzwords. It's more a search and data audience. So I zoomed in specifically on that side of what we're doing in search and semantic search. A lot is being done. As I said, sparse search, neural sparse search, dense search, and we're now releasing a 3.1. It's already available. You can check it out with the search relevance workbench that is designated for you to compare different models and see which semantic searches work best and so on. So a lot is being done, but happy to hear about your specific challenges and see how we can.
Sure. Thank you.
Thank you. Any other questions? Last question. Okay, I thought I saw a hand there before, but I guess it's no longer around. Thank you very much, everyone, and I'm here happy to help. Thank you.